Now we're going to code a circular buffer example in Java using a class called circular buffer. This is going to maintain the actual data inside the circular buffer, and internally it's going to be an integer array. Circular buffer will actually be an array named data of integer objects, and you have a head and a tail position inside the array. We're going to use Java code to treat the array as a circular buffer. So when you first start, you create a circular buffer object using the constructor, and you set the number of integers you want to store in the circular buffer. This is going to create the new integer array to the number of integers you have passed to the circular buffer constructor, and it's going to store that as the data array. So you could store an array of 100 items or 1,000 items or 10,000 integer items if you wanted to. You just pass that number to the circular buffer constructor. We're going to initialize the head and the tail positions both to 0. Then we're going to have a method called store. Store is going to, as its name indicates, store a number in the circular buffer. And if you want to store a value, you just pass that value to the store method, and the store method is going to return true if it's a Boolean value. It's going to return true if it was able to store the value, false otherwise. So it's first going to check if the buffer is full. So if the buffer is not full, we're going to create a buffer full method down here that's going to return true or false whether or not the buffer is full, indicating whether or not the buffer is full, and we're going to create that method in just a moment. So if the buffer is not full, we can store a data item, and the data item you write to the tail. So you store the data item in the data array at the tail location and then increment the tail location. So that in one line really is the essence of the whole thing. You store the storing process. You store data at the tail location in the data array, and then you increment the tail location. You have to check if the tail is equal to the length of the array. It's the last item in the array. You're going to have to wrap it around and bring it back to the 0 location again. So if the tail item is at the end of the array, you're going to have to bring it back to the beginning. So first you try incrementing it, tail location, and if that doesn't work, bring it back to the beginning. In that case, we return true because you're able to store data. Otherwise, you return false. This buffer full method returns true if the buffer is full. And how does that work? So if tail plus 1 equals head, if the tail is right behind the head, then the buffer is full because you write to the tail, and there's no more space to write to the tail. If the tail is right behind the head, return true. Otherwise, you can also say if the tail is at the end of the location and the head is at the beginning of the array, then that condition also means that the buffer is full. You return true, otherwise you return false. So that's the buffer full method. To read data from the array, you just need a read method. And you're going to read from the head location. So if the head is not equal to the tail, then you're able to return a value. You're able to read a value from the array, and you say that value is equal to the head location in the array. And so you say data head, and then after that's executed, you can then increment the head location and returns the value. So that line is essentially how the reading of data happens from the array. You read from the head and increment the head and return the value like that. And if the head is equal to the end of the array, you reset in other words, after you've incremented the head, if the head is at the end of the array, past the end of the array, actually you reset it to 0, and since you were successfully able to read a value from the array, you return that value. Otherwise, you return a value of null. That shows that the read was unsuccessful because there's no data, and you have to return a value of null. So that is the implementation of the circular buffer class, and we're going to put the circular buffer class to work coming up next as we test it out.